Good evening, this is Mr. Wintermelon. So in the previous video, you have learned about the anatomy of our respiratory system. And in this video, you will learn how some of the part not mentioned in the anatomy of the respiratory system is involved in getting the air in as well as air out from our lung. So this is the syllabus expectation of you. You are supposed to describe the role of cilia, diaphragm, ribs, as well as intercostal muscle in breathing. So you can see that diaphragm, ribs, and intercostal muscle was not previously mentioned in the syllabus outline in the anatomy of our respiratory system. So go figure why they suddenly pop up right here. Hello, SEAB, what the hell are you thinking? As for cilia, the main knowledge that you have to know is what happened to cilia when you smoke a lot or smoke a bit. It will cause cilia to be paralyzed and it will affect breathing because they cannot sweep the mucus out. As for normal cases, healthy individual, you don't have to care about what cilia does during breathing because there's nothing. It is there to clear the airway. So for this video, you will learn about breathing, and in the next video, you will learn about gas exchange. In breathing, there is inhalation as well as exhalation. This is a fancy way of saying breathing in as well as breathing out. As for the gas exchange, the molecules that are exchanged are oxygen as well as carbon dioxide. I don't think this is a surprise. But in this video, we will be focusing on breathing in as well as breathing out. Now, the thoracic cavity is the space in our chest that stores our lung. So, what are the important components that causes the air to be forced into our lung and causes air to be forced out? They are our vertebrate column, not important for your syllabus. Sternum, also not important because you can see that it's not inside the syllabus outline. Our rib cage, diaphragm, external intercostal muscle, as well as internal intercostal muscle. Now, to some of you, it might be a bit difficult to remember which muscle contract and which muscle relax. Don't worry, I'm here to help you. What you have to remember is two words. First is Eric, the other is DEI. You might not understand what is Eric, but at least you should be able to see what does DEI stand for. Why DEI, you might ask? Because you do not want to die. If you spell as DIE, you will die. So spell it as DEI. Diaphragm, external intercostal muscle, and internal intercostal muscle. Diaphragm is the muscle underneath your lung. So how about the Eric? Eric is actually the more important thing to remember. So what does it stand for? E for exhale, R for relax, I for inhale, C for contract. So when you exhale, the diaphragm will relax. When you inhale, diaphragm will contract. So what you have to remember is what happened to the diaphragm, and that is sufficient. Because you can reason out the rest. Remember, I asked you to keep in mind DEI instead of DIE because you do not want to die. So diaphragm and external intercostal muscle, they contract and relax at the same time. So when diaphragm relax, external intercostal muscle will also relax. When diaphragm contract, external intercostal muscle will also contract. So the D and the E, they contract and relax at the same time, while internal intercostal muscle is an antagonistic muscle to external intercostal muscle. So whatever the external intercostal muscle does, it will do the opposite. So when the external intercostal muscle relax, internal one will contract. When the external contract, the internal will relax. So very simple. You just have to remember Eric. When you exhale, diaphragm will relax. When we inhale, diaphragm will contract. And external follows diaphragm. Internal is the opposite. So now I will take you to see a model of a lung. What I have down here is a simple model of a lung. I will be uploading a video showing you how you can make this at the comfort of your own home. The material needed is quite simple. You can see two straws down here. They are used to represent our bronchi. The hole in the straw will allow the air to be forced in as well as forced out from the balloon, which is obviously used to represent our lung. The plastic bag below is used to represent our diaphragm, while the bottle that is sawed into half is used to represent our thoracic cavity. Thoracic cavity is the space in our chest where you can find your lung. Take a look at what happened to the balloon or our lung when I pull down the diaphragm as well as push up the diaphragm. So when I pull down, the lung actually expands. When I push up, it shrinks. Expand and shrink. Expand and shrink. Expand and shrink. Breathe in, breathe out. Breathe in, breathe out. Breathe in, breathe out. Next, what you have to figure out is when is the diaphragm contracting and when is the diaphragm relaxing. What I told you to remember just now is ERIC. E-R-I-C. So ER, when it's exhaling, it is relaxing. So when the diaphragm is pushed up, it is relaxing. Then when it's pulled down, it is contracting, because in this state, it is inhaling. E-R-I-C. Inhale, contract. Inhale, contract. Exhale, relax. Inhale, contract. Exhale, relax. Inhale, contract. Exhale, inhale. Exhale, inhale. So go and make a model of the lung, or if you are too lazy, just watch this video so that you have a good mental image of what happened when the diaphragm relax and contract. When the diaphragm relax, is being pushed up. When the diaphragm is contracting, is being pulled down. Relax, contract. Next, what you have to understand is how does this work. To fully appreciate what is going on, you have to know two things. The first thing is pressure and volume, they have an inverse relationship. What does inverse relationship means? It means when the volume increase, the pressure will decrease. When the volume decrease, the pressure will increase. The second thing to understand is there are two space or two volume that we are talking about. The volume of the thoracic cavity as well as volume of the lung. So look at what happened when I pull down the diaphragm. As I pull down the diaphragm, the volume in the thoracic cavity will increase. So as the volume inside the thoracic cavity increase, what will happen to the pressure? Volume increase, pressure will decrease. So since the pressure in the thoracic cavity actually decrease, it will become lower than the pressure inside the lung. So since the pressure inside the lung is higher, it will cause the lung to expand, and when the lung expand, the volume in the lung will become larger, and when the volume increase, the pressure inside our lung will decrease. So since the pressure inside our lung decrease, it will drop to be lower than the atmosphere. And when the atmosphere pressure is higher, air will be forced in from the atmosphere into the lung that have a lower pressure. Next, take a look at what happened when I push the diaphragm up. When I push the diaphragm up, what will happen to the volume? The volume in the thoracic space will actually decrease. So, volume decrease, pressure in the thoracic cavity will increase. With increased pressure, it will be higher than the pressure inside the lung, causing the pressure in the thoracic cavity to push against the lung, shrinking the lung as a result. As the lung shrink, the volume in the lung will decrease. Volume decrease, pressure will increase. So pressure in the lung will increase and it becomes higher than the atmospheric pressure. So air will be forced out from the lung since the pressure in the lung is higher than the pressure in the atmosphere. And this is the reason behind the lung expanding and shrinking as our diaphragm contract and relax as we inhale and exhale. So go and make yourself a model and play around with it so that you will have a good mental image of this and you will be prepared for your O-level exam. So to put the two process in words, during exhalation, Eric, our diaphragm, what will happen to our diaphragm? ER, exhalation, relax. Then our external intercostal muscle, what will happen to it? It will follow our diaphragm. Because we do not want to die, that's why we spell as DEI. So muscle will relax, then internal intercostal muscle, what will happen? It will do the opposite of external intercostal muscle, which is it will contract. So our rib cage and sternum, this one, like I say, in exam you can do a bit of cheating and squeeze out the air inside your lung. What will happen is your rib cage will move downwards as well as inwards. So you can imagine it will squeeze and reduce the volume of the thoracic cavity. So the thoracic cavity, the volume will actually be reduced. So it will be decreasing. And volume and pressure have opposite effect. Smaller volume, the pressure will be higher. So pressure will increase. So when the pressure surrounding the lung increase, what will happen to our lung is it will collapse. Because the pressure outside will be forcing the lung to be smaller. So since the lungs become smaller, the volume decrease. Volume and pressure, they have an opposite effect. When the volume decrease, the pressure will increase. So it will be higher than the atmospheric air, and the air will be forced out from the lungs into the atmosphere. So please take note, use the word air is forced out, or later on air is forced in. Do not write flow in or do not write flow out. Because if you write Flow, the asshole in Cambridge will not give you the mark. It will be penalized if you write flow. You must write forced. And we can write the opposite for inhalation. Remember, Eric, E-R-I-C. Just now it was exhale. So exhale, the diaphragm will E-R. That means exhale, relax. Then now for E-R-I-C, the I-C, inhalation will be contract. So our diaphragm will contract. External intercostal muscle will contract as well, following the diaphragm. Internal intercostal muscle will relax. So remember, DEI, because we don't want to die, because die. Then our rib cage will move upward as well as forward. This will cause the volume in the thoracic cavity or the space surrounding the lung to increase. So with increased volume, the pressure will decrease. Our lung will expand. So the volume become larger, then the air pressure in our lung will become lower. So since the air pressure in the atmosphere is higher than that of our lung, what will happen is the air will be forced in from the atmosphere into our lung. And again, let me emphasize that it is forced, not flow. Please write force, because the change in pressure will cause the air to be forced into our lung. And this will be all for the mechanism behind exhalation as well as inhalation. In summary, you just have to remember Eric. Exhale, relax, inhale, contract, and this applies to the diaphragm, and your external and internal intercostal muscle will follow the sequence of DEI. Diaphragm and external will contract or relax at the same time, while the internal intercostal muscle is antagonist, so it will be opposite. Just remember Eric, just remember diaphragm, and just remember don't die, and you will be fine.